Okay, so I forgot that the generic list in C Sharp, I hardly ever used C Sharp. It's kind of almost before my time. So what I mean, lists in C Sharp, generic lists. I've used some other languages. So I forgot what's called array list. So you had something like this in Java too, sort of a similar concept. And remember I said underneath it's actually an array, but it sort of acts, it behaves as if it were a list in the fact that you can add and remove things to it. So it's kind of faking. Hopefully best of both worlds is the point. But regardless, let's go and look at it. So again, I retooled all this. You can see I've renamed everything to make sense. So we're still going to do our work in this button. So I'm going to do the old-fashioned list, which is an array list in C Sharp. And in order to do that, you got to make sure you're using system.collections. So I took the system.collections.generics out because that's that's there by default usually. System.collections.generic are the new kind that you really want to use, honestly. But there are maybe particular tasks that the old kind are suited to, and you might find those tasks at some point. But but I had to take that out and put this one in. I could probably have both in, but I just took the other one out and put this one in. So you'll have to redo your using up here in order to do this. So down in the code, so what happens when I clicked on the button? What happens is I create a new array list. I just call it list. And then I do this just randomly, so to speak. We're talking about dice, so random, right? Get it? Anyway, I added the die class that I have from another example, if you might remember it. It's not so important to understand how the die works. All that's important is to understand that I have an object, have a class that I can instantiate into objects, right? Don't forget your nomenclature there, your terminology. This looks like a work in progress itself, but it doesn't even matter what's in here, the specifics. All you have to know is that this is an object. It's not just a value like 3, or it's not a double, 2.7. It's an object, which doesn't have just one value except the reference in memory to where it exists. So I create a new die object. Here's the die object. I assign this die object's address to this variable called die. And then what do? I add an integer 2 to the list. I add the literal string happy to the list. And by the way, I could do, I could do variables too. So let's add one right here. List.add num. There we go. The thing is, you can add anything, almost anything, because everything's an object. And that's what you add to lists. So what it does when you add something, the add method says, okay, what is this thing? Oh, it's an object because everything is. So I'll add it to the list. This is where inheritance, polymorphism, that's pretty much the terms I need to, yeah, polymorphism. It's polymorphism. So since everything is an object in the inheritance terms, and if the parameter for this add method is an object, let's see what it is actually. See, object, lowercase, object's the name of a class. It gets confusing, I know, but there's a class called object in C Sharp, and everything inherits from it. Everything that's an object, like most of the stuff you work with, are objects, including just the integers, an N32 object. Technically, they are objects as well, even though they're really just value types. It gets confusing, I know. It does for me too. But anyway, so you see that you can add any kind of object. So you can basically add anything to this list. So what do you do with these things once you add them to the list? Well, you could iterate over them. So what I want to do is like iterate over this list. I want to make it roll the dice. So this is what happens. This is the drawback to this stuff. Here's the list box I'm going to print results in, which I don't have any yet really, but I'm going to do demo, and what happens? I immediately get an error. Why? Because item, the first item that it sees is probably 2 here, which is an integer. It doesn't know how to cast that to a die because it's not a die. It's an integer. So that's the drawback here. If these were all dice, let me show you. So, because I know this is confusing, but let's do the case where everything is a die on the list. So where am I at here? List.add. And this might be confusing for you. I don't know, but I hope not. But let's do a coin flip first, right? That's a two-sided die. List add new die. I can't imagine it in 3 dimensions. The 3-sided die. It would be really weird. It's probably possible somehow or another, but it's not a platonic solid though. It's definitely not that, because there's no 3-sided one. There is a tetrahedron though. That's the 4-sided die, which you might be familiar with if you play D&D. We'll do a hexahedron, otherwise known as just like a die. That's the kind you're like fuzzy dice. Octahedron, an 8-sided die. It's like 2 pyramids, square with square bottoms, put bottom to bottom, right? 10-sided die, which has got the kites on it. It's not a platonic solid. It's not a platonic solid. Why can't I do a new die? This is what I hate about IntelliSense sometimes. New, add. What's off here? Oh, the dot. Little typos cause big problems. Here's a 10-sided die. That's the one with the kites on it. Now, it's not here. It doesn't have any concept about polyhedra. What I'm doing, it just knows that randomly select from a certain number of things. But if you wanted to represent this with real dice in the real world, these are the ones you would use, right? A dodecahedron for this, and then we'll do the last common D&D thing, which is the icosahedron. I'm not sure, but that's the the biggest platonic solid, regular solid. Anyway, so let's do this. The roll, I think, returns an integer, so we can go ahead and add it to the list box. LST output dot items. And by the way, that's sort of what the whole list thing we were talking about before. That's kind of what's happening here with this list box. You can add any object to these items. They're just objects. So it's very similar to the array list up here, but we won't talk about it too much. Let me get rid of this. I don't need this. And notice I didn't have to create variables for each of one of these. I'm just creating the new object, the new die, and immediately adding it to the list. So you don't even need variables sometimes when you're working with objects, but that's another topic for another time. So let's run this now and see what we get. It works. Each time I click it, it'll just add to it. I probably should clear after each one. Let's do that real quick. We don't want to clear here, we want to clear here. If we clear at the bottom, we won't ever see the output because it will immediately clear. But if we clear as soon as we push the button, it sets it up for the new stuff, right? I swear. There you go. This is how you clear a list box. Not stuff you necessarily need to know right now, but could be helpful later. So that'll make this demo more sensible. So heads, tails, heads, that's on that first one, right? That's the coin flip. The third from the bottom, that's like rolling in TI, Twilight Imperium, to see if you hit. My carrier hit. All right, anyway, so you get the idea. So this just works. It doesn't, notice it hasn't crashed yet. Now, technically speaking, we should probably have some try catches and stuff in here for a robust program. But don't worry about that for this kind of thing, especially a demo. So why does it work? It's because every one of these objects that I pull off is a die. Every item is a die. If I did just do this, by the way, if I didn't cast it, what would happen? Why can't I just roll the item? Because we know it's a die, right? Well, we know it's a die, but Visual Studio doesn't. C# doesn't. We know as the programmer that we added a bunch of dice to the list, but it added them. When it does that, it strips the diceness off of them. That's Dice is plural. Now I'm trying to be adamant about singular versus plural, but it strips the die-ness off of each one of them and makes it a generic object. So at the moment that it's living in the list, it's just generic. It has all the structure of a die, all the parts, but to C#, it looks just like another object. It's just a memory address. It doesn't know how to operate with it. In order to operate with it, you have to have a variable of that type to give C# an idea of what kinds of methods it has. So if you say object.roll, here's the thing. This what I'm doing right here. Oh, I can't do it. Too excited to type. I don't know why I'm excited. This is kind of boring, but you can. It's not a what do you call it? You can implement objects. They're not. Dang, concrete versus. The word's slipping from my brain right now. Let me pause and find it. Remember it. Okay, I had to take the pressure of the video off for like 3 seconds. Abstract. It's not an abstract class. You can instantiate an object. But when you instantiate an object, in this case O, here's all the things you have. So it knows, okay, an object has all these methods and properties and stuff. But it doesn't have a role. In order to know that a thing has a role, you have to cast it to that data type. This is probably really confusing, and I apologize for that, but there's no way around it really. Because I want you to truly understand the whole, if you read the book, it sort of tells you all this, but it doesn't tell you in the way I'm showing you. So let's get back to where we were. So this is how it would be useful. What you would have to do is process these things, especially if you had things mixed together, you would have to have like if statements. So you would say if item is die. If it is, then you can do this. So, and then like, let's just say that everything else is a simple value type. I'm not even sure if that would work. Else, working with these is kind of a headache sometimes. So okay, sorry, I got distracted by stuff that happened in the house. We have a dog that bites other dogs, and he's got a new muzzle, and it's a long story. Anyway, it was cute. Okay, so we were adding things to. Okay, so as long as we keep this to value types, I think we'll be okay for just adding it to the list, and it will display there. So what I'm saying is that you can mix into this list.add like 23 maybe, or list.add I'm sorry, not add, but it is add, right? What's a good word? L1Z1X. I've been playing a lot of Twilight Imperium lately, so that's where that comes from. So when you run this now, cross your fingers. Still works because those are just value types, and it can sort of figure out how to do a toString of them to add to the list box. But how would it do a toString for a die? And how would it roll the die first? It has to know it's a die. So this is typically how you would use these in the past. You would have some kind of thing that would figure out using this operator. This tells you what type something is. So it's saying if this is asking the question, is this generic object that I pulled off the list, is this object actually, if you check it for me, computer, can you figure out if it's a die object? If it is a die object, then create a variable that's a die variable and cast this to it so I can use it. So I can access through this variable the roll method. So I'm going to roll, and I'm going to add the result, which is an integer, to the list box. Otherwise, just add it to the list box, because it's probably, me as the computer programmer is trusting that everything that's not an object of this type is probably just a value object. And strings technically are reference objects, but they get treated as if they're simple values. So and just add it to the list box otherwise. This is the kind of thing you'd have to be sure about and get exactly right, or you would get crashes if you mix different types of objects, again, everything's an object in C#. I'm 100% probably not, but like just in for our purposes of talking about this, all these data types we use are objects. If you go back in their history far enough, their inheritance, their parentage, their pedigree, right? They go back to objects, so they can all be stored on something that stores objects. That's polymorphism. But if you try to process them as if they're specific subtypes and you get it wrong, you'll probably get some kind of crash. So there's plenty of robust code written in the ancient times and other languages that used a similar principle, C and C++, that worked fine, but you had to do a lot of extra work to make sure everything ran properly. And typically you don't want to mix things together in a data structure anyway, but I guess it depends on the specific task you're doing. That's enough. That's 15 minutes. That's way more than I want to talk about typed versus untyped. So this was untyped. This is sort of the old-fashioned way of doing it. From now on, I'm going to be showing you typed. I'll refer back to this, but I'm not going to make a big video about typed. I'll just start doing the specific ones and showing you how they work, and I think it'll be intuitive how they're different and the pros and cons for how this did things versus the new way. So if you have any questions, again, I keep saying I don't need to say that every video, you know, to email me. So I just need a closing. So the end.